Ready.
Okay, this is one of the question based on pressure. Look the question first time, after that I will clear the board. The following data were obtained during first order thermal decomposition of N2O5 at constant volume. Volume is constant. The reaction is twice N2O5 gas, it produces twice N2O4 plus O2 gas. Here time given, pressure given, time is given in second, pressure is given in atmosphere. When the time 0, the pressure is found to be 0.5 atmosphere, and at time 100 second, the pressure is found to be 0.512. Now you have to find out the rate constant, I mean you have to find out the value of K. And since here pressure is given, that's why you have to use the pressure equation, don't use the concentration equation. Now here initially the pressure which is given 0.5, initially you will get the pressure only from the reactant, because initially no product will form. Ultimately at time 0, this is the pressure of the reactant, I mean initial pressure of the reactant. And at 100, when the time is 100 second, the pressure going on increasing 0.512, because at time 100 some amount of product also form, and product also gives some amount of pressure. That's why as the time proceed, your pressure going on increasing. That's why it is 0.512. Now you have to determine the rate constant. So here I will write the equation. As the equation given, twice N2O5 gas, it produces twice N2O4 gas plus oxygen gas, O2 gas. At time 0, I mean at the beginning, when time at the starting, when no product will form, then the pressure is given 0.5 atmosphere. And at time 0, I mean at the beginning, no product will form, that's why the pressure of the product will be 0. When the time becomes 100 second, as you know, as the time proceed, amount of reactant going on decreasing. So suppose X amount going on decreasing, so it will become 0.5 minus twice X. Since it is 2 mole, that's why I have written twice X. So it will produce the pressure twice X, it will produce the pressure X at time 100 second. Because as you know, as the time proceed, some amount of product will form. So with the reactant, product also gives some amount of pressure. Now what about the total pressure? When you write the total pressure, 0.5 minus twice X plus twice X plus X. I mean you have to consider both the pressure of the reactant and the pressure of the products, that is the total amount. So twice X will be cancelled. Ultimately you can write PT is equal 0.5 plus X. So you have got total pressure PT is equal 0.5 minus X. So X is equal, you can write 0.5, 1 minute, 0.5 minus PT. This is about X. No, something wrong. Twice X cancel. So it becomes PT is equal 0.5 plus X. So X is equal, just to push it. So it is PT equal 0.5 plus X, that's why it is wrong. X is equal, you can write PT minus 0.5. So total pressure is given 0.512 at time 100, 0.512 minus 0.5, that means you will get 0.012. Just I have find out the value of X. So now you know, to determine rate constant, it is equal 2.303 divided by T log of initial pressure divided by present pressure. Initial pressure we know, in the table it is given initial pressure is 0.5 atmosphere. Now we have to find out the present pressure, I mean at time 100 second. So at 100 second, in the equation you have written, what is the pressure of N2O5? pressure of N2O5 is 0.5 minus twice x. 0.5 minus twice x. Matlab 0.5 minus 2 into x value already you have got 0.012. That means 0.5 minus 420, 0.024. That means you will get 0.476 atmosphere. This is the present pressure of the reactant. Now you can use the equation, rate constant equation. K is equal 2.303 divided by T log of initial pressure Pi divided by twice Pi minus Pt. Already you have got the equation. You apply the equation. So K is equal 2.303 divided by time is 100. We consider 100 second. Log of initial pressure is initial pressure was given 0.5. 2 into initial pressure 0.5 minus Pt. Already you have determined total pressure. Sorry, not total directly you can put initial pressure is 0.5. Now this present pressure is 0.476. Directly I put the value. This is the present pressure and 0.5 is the initial pressure. After doing this, when you calculate it, you find out the log value. This becomes 0.02303 into log of 0.5 minus log of 0.476. When you calculate this thing, then you will get the value 4.6 into 10 to the power 4. Unit will be second inverse, because the time is given in second. That's why the unit you will get in second inverse. So like this way you can determine the value of rate constant from this pressure. So if pressure is given, you apply the pressure equation, and if concentration is given, then you can apply the integrated concentration equation. Thank you.